Hello, ma'am.
Hello. Yes, Shrishti. You can share your screen. Just give me a minute, no? I'm coming back.
Oh,
Yes, Shruti. You can start. You can share.
ma'am, this is my diagram.
Okay. Okay. So can you explain it a bit from where it is starting and then?
Uh, then after downloading the data, I
Hmm.
buffer a river network, roads, there is hydro lake points. In
Hmm.
each parameters, like river network is 500 meters, roads is 200,
Oh,
hydro lakes 200. Hydro lakes polygon is also there, so I take it 200 meters also. Then I extracted them and them with the low elevation,
mm-hmm.
below 15 meters. So that elevation I extracted. I have the raster land use land cover layer. So
Okay.
I extracted the agriculture, filtering agriculture part only.
Mm-hmm.
Uh, then I have the settlement area, then hydro basin. I does not do any buffer in that. I take there's a full fletcher settable area, and
Okay.
then I have to. Then I also have rainfall data. So first I have to overlay by using the FHP method or weighted overlay analysis method. Then I want to intersect the district area, then the flood level analysis uh, by area based district area means I have to do.
So the data set that you have are Just a minute. You have a LULC raster, correct? And next, what other things that you have?
Hello?
Hello, yeah, am I audible?
It's not.
Yes. So I'm asking what all data you have. I'm just listing it out. Can you tell me? LULC raster,
Okay. Yeah, in the LC raster, then I have roads.
road buffer. You created a buffer for roads. For how
Yes,
much
ma'am.
meter you created?
1 minute.
What distance have you gave for raster buffer? A road buffer.
Road buffer, it is 200 meters.
200 meters?
200 meters.
Okay. What?
Road buffer.
Okay. What's other?
The river buffer, 500 meters.
River buffer 500 meters. Okay.
Then lake points, that is 200 meters.
Lake points, and you created a buffer for that as well, right?
Yes, ma'am. 200 meters.
Okay.
Then lake polygons also I have, that is equal to 300 meters.
Lake polygon buffer as 300 meters. Next.
So I have next I have settlement and hydro basins that I have not buffered. Yeah. Hello, ma'am.
Just a minute. Okay, after lake polygon buffer, what else you have?
What I have dim,
You have dam.
uh, then low elevated dam I have. I created low elevated dam. Then slope I
Okay.
created
Just a minute. Low elevation. So
dam.
you have only extracted the area which have low elevation, right?
Yes, ma'am.
Okay, just a minute. So you had the whole dam, and then from that you extracted low elevated areas. And what's the range that you took for this?
Uh, Less than 50.
Less than 50 meters,
Is
not
abandoned.
meters.
No, no. Less than 50. What I took.
Hello?
Hello, ma'am.
Yes. After extracting the low elevated area, what's the range?
What's next?
Okay. What is next?
Uh,
In terms of
Ma'am,
the
I
lake.
have in my hand, I have already hydro basin settlements and the rainfall data.
hydro basins,
settlements,
settlements, and
rainfall,
rainfall. So for rainfall, do you have points or do you have a raster file?
raster file.
Raster file, fine. So now, since you have all these data, so when you are doing the AHP, at that time, are you putting every single layer that we just discussed as a parameter and you are applying the weightages to it?
I rasterize the files that are vectors.
Mm-hmm.
Then I put uh, each layers as we discussed.
So all these, you haven't combined any of the data. So the thing is, let's suppose that you have a lake point buffer and a lake polygon buffer. So either you combine these two data set into a single file and then use it in your data set. Why? Because giving all three layers as a separate layer is not recommended in AHP. So when you were studying you must have studied in papers and everything. You create a final data set that you put in AHP. So you can have multi-source data that you can create for putting into AHP, but you cannot put every single layer as a separate layer and apply the weightages to it. So because river, lake, and they all act as a single thing, right? They are all representing a single water body. You want to represent it as a water body. So they will all act as a single data for your AHP, where you will apply a single weightage into this data. So either what yes.
Ma'am, I am in hostel, so that the background noises.
Okay. Your side
Hello,
or my side?
my side.
Okay, no, it's not coming. It's fine. I'm asking, okay, I was telling that let's suppose you have a lake point buffer and a lake polygon buffer and a river buffer. You cannot put three same kind of a data as a different layer and apply the weightages to it. Okay, so first thing you have to do is basically to combine these data sets. You can have river and lake data as a different data. Why? Because maybe river has a more impact on the flood rather than a lake data, but lake point file and lake polygon file will have a same weightage. So they cannot be put as a separate files. So they have to be in a single file. So one thing, you created a buffer in the point also, in the polygon also. So ultimately that layer become a polygon layer only. So what you can do, you can just merge both the layers into one single layer and then rasterize that so that you have a single data for the lakes. And then apply the rast. And then when you are doing the AHP, use that combined data for the lake. First thing is this. Okay.
Okay, ma'am.
Okay. So that is one point. Now, next thing is just a minute.
Sir, ma'am, one more thing. I
Yes.
have that agriculture filtering from land use land cover. I also have that data.
So, in that also, I have a recommendation. Just a minute. What is the reason that you have filtered the LULC for the agriculture only?
Ma'am, for flood analysis, I have the settlements and built up, so if
Hmm.
the layer of agriculture or crop is there, it will be more useful, or it is better analysis creation. That is why I choose this.
Hmm. Okay. But when we are doing but when you are doing the analysis, at that time you shouldn't like filter the data. Like you should use the whole LULC data for a upper level, you can say that for a upper level analysis. You shouldn't filter it just to have the agriculture. You can assign the weightages, because as I mentioned, I'll come into that part that once you are doing the reclassification, so at that time when you are doing the reclassification, and then on the basis of the classes, that when we will assign the weightages and everything, at that time you can assign more weightage to the agriculture and assign a less weightage to the other classes. And then for the settlement layer that you have, so you can use that settlement layer as an overlaying layer as the later part of your analysis for deducing the for exactly defining the zones area from your settlement layer, that okay fine, these are the settlement boundary or the polygon areas that are more affected by the flood. So upper level analysis should be done in the whole LULC, because the upper level, because if you are just scraping the water body, the built up, the barrier and the vegetation from your LULC, and just picking out the agriculture, you are just doing putting the bias into the AHP actually. So this will not give you the actual accurate result. So even if in the past studies also you will see that whole LULC is preferred over filtering into that single LULC in that, or filtering the single agriculture into that. When you only use agriculture data, let's suppose when you're actually studying agriculture study, or you are doing the flood analysis for that agricultural zones only, but I feel that you are not doing the flood vulnerability analysis for the agriculture zones. You are doing it for the overall area. Am I correct?
Yes, ma'am.
So when you are studying it for the oral area, you cannot just let everything put aside. You have to bring the whole LULC, and then for let's suppose you have a settlement area. That is also, you cannot just put the settlement area and assign the weightage to it. I'll suggest that you should use the settlement area as an overlay analysis after you get the output from your settler from your AHP. Let's suppose you got the zones like the high, low, and the medium from the AHP, and then after that overlay your settlement polygon layer into that, and then now overlap the whatever settlements that are lying in that high zone area or high flood vulnerability areas. Those settlement will be the in higher risk zones. In that way, you can build your study. Like I'll suggest that you should go in that order. That is second. You can choose, that is up to you. You should read more papers in order to, because like choosing the parameters and choosing the layers is like one of the key things that one should do when you are doing the AHP. So filtering agriculture is just a complete no from my end. And you can also look up to more papers as well to fully make up your mind that okay fine, this is the reason I'm filtering out agriculture. uh, I'm not filtering out agriculture. And just a minute. Okay, what's the first point that I mentioned for the change? Uh,
My
I just,
first point is lake points and polygons I have to
huh,
merge.
yes. So first thing I suggested was to merge similar kind of data. So the takeaway from here is that similar uh, datas should be put in AHP as a single parameter. Okay.
Ma'am, one doubt. If I
Yes.
have the vector layers, all vector
Mhm.
layers, can I merge?
Yeah, or no, no, but that is not recommended because see, what AHP is, let's go backwards. AHP is basically you have to assign the weightages to the parameters. Means my this parameter is highly preferable or is likely most, it will affect more to the flood, incoming flood. So on the basis of that, we are deciding the parameters. So you cannot merge all the data set. Right, because let's suppose you cannot merge your slope and low elevated areas together. No, you cannot because your slope will have a different weightage or a different effect to the flood. Your low elevated area will have a different weightage. You have to decide that which is more and which is less. Similarly, I'm like I said, like you cannot merge river and lake together because river body is large. River will affect more to the flood, whereas lake is usually it can also be found inside the city as well, and it is a low depth lake as well. So lake might affect less to your areas. Or for example, if you think that in your it can change also. Let's suppose that lake is lying uh, very close to the settlement areas. So in that case, that lake can also be a problem. So in that case, you will first study your study area as well. Okay, fine. In my study area, maybe these are the settlements, or here there is more cluster of the buildings, and there are 2 3 lakes present. So these areas more likely to be affected to the flood. So I will assign more weightage to the lake because it is in proximity to my buildings or the built up area or the livable area. So on the basis of that to decide the weightages, and then on the basis of that you decide the parameters. So parameters should be similar and it should add value to your output. On the basis of that only we decide the parameters. You cannot merge everything together. Okay. So first thing is lake thing should be merged, and then another that I suggested was to do not filter LULC. Put your LULC as it is, and as 5 classes important. And then I will suggest that use the settlement bound polygon layer as the overlay layer after you get the result from your AHP. That was uh, second. And then you have missed very important parameter that people use for flood risk analysis, that is to flow accumulation. You haven't calculated flow accumulation. So you should calculate the flow accumulation. You can calculate it from the DEM data that you have. So calculate the flood accumulation, because what it will do, it will identify the water convergence zones on the basis of the uh, flow of the water in that particular study area. It will find the potential flood zones as well. And you should give more weightage to the actual what flow accumulation will do. It will give you the how actually on the basis of the terrain how the water will flow into any kind of a city. So let's suppose people these days why flash floods are happening. Flash floods are happening because people are making buildings, roads, and they are building obstruction in the natural course of water. So so if you want to know that in my city which area is more affected to the flash floods, you should know that in what part of my city I am obstructing the natural flow of the water. So in order to answer that question, you have to know the flow accumulation of your study area. So just calculate the flow accumulation and put it as one of the parameters as for the AHP, because it will give you the natural, because the rest of the other parameter are just the outer and the external parameters for the flood. But the main parameter is what is the natural flow of water in your city. That will give you where the water will converge, where the water will flow naturally. So the natural water conversion zones you'll only be able to get using flow accumulation. So you can just write that calculate the flow accumulation as one of the parameters. Okay.
Ma'am, is
Hmm.
there any need for the calculation of aspect?
For aspect,
Aspect, slope, direction.
Aspects is it's not necessary. You can skip aspect. It's not really important for
Okay,
this.
ma'am.
Hmm. Another thing is drainage density. You should have a drainage density. Uh, you are using the river buffers, that is fine, but it will not include the drainage density. What drainage density will give? It is one of the important factors for flood indicators. It will give you that in which area there will be high runoff concentrations present in the area where the main when you will calculate the flow accumulation. So flow accumulation is the middle step, and after calculating the flow accumulation you can calculate the drainage density as well. So you can look for the I'll also share you another paper where they are calculating every single uh, parameters that one should use for calculating the flood. So you should use drainage density as well. It will give you the high runoff concentration and add flow accumulation. So final parameters will be drainage density, flow accumulation, your river buffer, your lake buffer, then LULC, and
Ma'am, hydro basins is there.
yes,
Can
okay,
merge or something.
mhm, just a minute. Okay, so what are hydro basins? Can you just tell me?
Ma'am, hydro basins is the outlets of all the rivers in an area. We can join together by giving hydro basins.
Okay.
Hello.
And why do you think that it is necessary for calculating the flood susceptibility?
Uh, then can I omit that?
Hmm? Sorry?
Can I omit that layer?
Uh, you can,
Hydro
but you can
basins.
keep it also, but you should know the reason. Okay, you can go back and you can try to first study. My point is only that whatever layer that you are putting in your AHP, that should make sense to your output. Okay. So uh, take
Okay.
take a day more for hydro basins. I'm not asking you to omit that layer. I have already told you what to remove. But hydro basins, I am fine with hydro basins, but you should know why I am putting hydro basins and what it will add to my output. If is it really necessary, or is it fine, or if is it an adding, if it's adding any kind of value to it, you should come with that answer first. Okay. Otherwise, I'll tell you that why it
Okay.
is necessary, but first try to like search on your own that why hydrobasins is actually necessary for flood
Okay.
generation. Okay. The two parameters that I told that you should combine, that you should add into that. Okay. Okay. This is fine actually.
Ma'am, I have a doubt.
Yes.
Uh, Ma'am, for AHP calculation is
Hmm.
the my I am putting some values to the weightage like that. Is it correct or can I modify that?
The weightages value? The weightages value?
Hello, ma'am. Can I
Hello?
show that weightage value?
Yeah, yeah, you have already shared in that weightages values also. I was coming to that only. They needs to be changed. Okay.
Okay.
They are not up to the mark. Because I'll take example. You have put the weightage value to the slope as what is the value that you put? I guess 0.15, right? Can you show? Okay. So for slope, you put.
0.05.
Okay. So for slope, you put 0.05. This is very low. Why you put 0.05? Also one more thing. So three things I recommended that merge the lake, add drainage density and flow accumulation. Now there are two questions that I'm leaving you with. One is Why hydrobation should be the part of this AHP parameters? One is that. Another question is how you decide the weightages. If you have the answer, you can give me now. You should
Ma'am,
decide,
wait,
you should decide
wait.
the weightages on the basis how much that particular parameter is will contribute to my flood, to my output. So my output is how much flood will be there in that particular area. So what parameter will be affecting more into the contribution of the flood in that area? So why do you think that slope should be the lowest in terms of the contribution? I feel that slope is the greatest parameter because the higher the slope, the higher will be the reason that in that area there will be more flood present. So the you have given only 0.05. So this is very slope because the strong the slope is, it will control how your flood will flow into the city. Okay. So
Ma'am, the river network is also important and the slope is also important. So how can I distinguish? How can I
you
put
can put
the values?
you can put equal as well. You can put equal as well. There is no problem in that. The river, you can put it equal, or you can put more. Because if you compare it, and these all parameter that you decide, when you decide the weight, these are relative weights you decide, right? So if you are comparing between the slope and the river, so river will be more contributing towards the flood. So river should be more than the slope. But slope cannot be 5% only, right? Like it cannot be 0.05. This is very low. It should be at least 15 if you are putting a river as 20. How much you put for river? You if you have put river as 15, then you should put rainfall as sorry, if you should put slope as how much? You should put slope as 10, not like 0.05 and 15. This is too much of a difference, right? So, and also another thing that everything should be add up to one. Are you doing that? Have you like incorporated?
Yes, ma'am. Yes. I know that everyone should have it like one. I read
Okay.
the paper.
Okay. So that is fine. And then but this calculation is still like the how you should decide the relative one. This is still not correct. So I can, I'll create one. I have noted all your parameters now. I'll create one also. And there is actually a trick also to decide how much should I keep for which parameter. Actually, I forgot to search that. I didn't get any time. But I'll create that and I'll share it with you. Till that time, you can work on the parameters. And also, before that, I'll ask you to read 2 to 3 more papers and try to like make an understanding with why you are actually using those parameters. Okay. And why am since we are focusing on coding also, we will focus on coding, but when you'll go for interviews and when you'll go to the people explaining your project, so they will be more interested on your understanding about your topic, I feel, right?
Yes,
So,
ma'am.
so if you have a good understanding about why actually you are doing this, then it will be a complete good project, on my opinion. So spend a little time on this parameter again, and and then we'll discuss this again. Okay. And for the weightages, you can leave the weightages for now. Create the flow accumulation and all those things and merge these layers and everything. The weightage, I'll tell you the weightages. Okay. And then we'll discuss on that how to decide one.
Ma'am, one more doubt.
Mm-hmm.
Uh, Ma'am, after I creating the HP and all those things,
Mm-hmm.
can I run that Python console together and how can I make it as a tool? How can I add it to my project? Hello?
Okay, so means
I mean, so the all in all output, how can I generate and how can I? taking my project. You can written like coding. I want to copy paste in my project.
Okay, so you mean to say how you should present it
Ah,
at the
yes,
end,
ma'am.
right? Okay. So for that, what we'll do now, we'll create a Git repository. You know about Git?
Hello, ma'am.
You know about Git?
Grid.
Git, Git, Git. So what
Ah,
I'll do,
yes, ma'am.
so what we'll do, we'll host all the files in the Git. Okay. Obviously, you will not be able to we'll not be able to create a file where they are running this, but we will create a complete Git repository where we will save all these tool code and everything, and then we will create a application like a web application at the end of it, and then we will host that web application where you can show all your outputs, because your output you can get in terms of TIFF file, in terms of image file, right? So
Yes, ma'am.
you can create that web application and we'll host that as well into the Git, and then you can display that link to anyone to whom you want to present, or if you just want a PDF kind of a output, then also you can do it in that Git itself. The code you can put it in the Git, you will have a link. You can share the link to anybody so that they can access your repository in order to access what code you have run in order to create this tool. And then that's good to go. Or also you this ahp.py that you created, you can create a whole I mentioned about that instead of having a different file, you can create a complete common function-wise common.py file, which we will which we will like put it that like, this is the tool that anybody can use, and it is generalized. Just by changing the buffer and everything, you anybody can use that tool. That is also the way that we should go about it. For now, you can have these multiple files .py, but at the end, once like we are done with our methodology and the workflow is finalized, then we will modify your code. We'll put everything in a single file. In a single file, we'll create multiple functions for every single task, like loading the data, loading the parameters, resampling, and then running the HP. So that in a single file, you can call it as a automated tool to run the flood. You can call it as a flood vulnerability delineation tool, like that.
Okay, ma'am.
You are asking that only, right?
Ah, yes, ma'am.
Okay. So just one thing. Do you want it to present the outputs in the PDF only, or you want to create a web application?
I want both.
Okay. So, so in the next track, actually, that we are starting next week only. So anyways, we will be covering the WebGIS part, where how to create a web application, how to host and publish it. Okay. So for the time being, you can like continue your capstone project and you can just make everything ready, layers, outputs, and create a PDF by that time. Like in the last session, I discussed now to have a methodology slide and all those things we discussed, right?
Yes, ma'am.
Huh. So by that time, you can keep on doing that so that once you have an output, once I'll cover everything in the next track, then simply just uh, keep practicing along the way. Like as I take the sessions, you can use your data only and then start publishing it. Then at the end of that, you'll get a web application also. Okay.
Okay, ma'am.
Okay. So,
Thank you, ma'am.
okay, so for my from my side, I guess I only have to tell now how to decide weightages, right?
Yes, ma'am.
Okay. So, and you should work on the flow accumulation and all those things. If you don't get the papers for flow accumulation, all those things, let me know. I'll share one. Okay.
Okay, ma'am.
Okay. Okay then. Anything else?
No, ma'am. Thank
Okay.
you, ma'am. Thank you so
Okay.
much.
Welcome. Bye bye.
Good night, ma'am.
Good night.